Hello everyone. Today we'll continue with the phase rule. Already we had started in the previous class. So after in the previous class we had discussed about the phase rule equation and its statement along with the terms which are involved in it. So now we'll start with the phase rule second class. In phase rule this is your second class. So where we have to study about the criteria for phase equilibrium. So already we know a multi-phase system is in the thermodynamic equilibrium if there exist simultaneously three kinds of equilibrium. So in equilibrium there are three types, that is thermal equilibrium, mechanical and chemical. Thermal from the term itself, right, where the temperature remains constant. That particular type of equilibrium is called as the thermal equilibrium. In the same way, the second type is mechanical equilibrium, where the pressure remains constant. In the same way, the third one is the chemical equilibrium, where the chemical composition, or you can say the composition remains constant, right? So these are the three types of equilibrium exist in the phase equilibrium. So before starting with the actual types, we should know what do you mean by a equilibrium. So here equilibrium is defined as or is said to be in equilibrium. A system is said to be in equilibrium if the properties like temperature, composition, etc. of the various phases do not undergo any change with the temperature, and it's of two types. Once again, I'll repeat the equilibrium, right? Under the equilibrium, it states that a system is said to be in equilibrium if the properties like temperature, composition, etc. of the various phases do not undergo any change with the temperature. And here when you study about the types, there are two types of equilibrium. First one is the true equilibrium, second one is the metastable equilibrium. So here the true equilibrium, right, is defined as or in a system when you discuss about the true equilibrium, it can be say that when the state or when the same state can be attained by approach from one direction. For an example, when you take A plus B, right, give rise to C plus D. So this equilibrium, reversible reaction. So this equilibrium can be attained from either from right to left or from left to right, right? The equilibrium can be attained from either direction. That type of equilibrium is called as the true equilibrium. So here this can be attained by either by partial freezing or by the melting of ice. In the same way, when you study about the second type, which is called as the metastable equilibrium, which can be obtained only by approach from one direction, that is from left to right only. So here this equilibrium can be attained only from one direction, then it is called as the metastable equilibrium. If the equilibrium is attained from both the direction, from left to right and from right to left, then that is called as your true equilibrium. Is it clear? So these are the two types of equilibrium, where the if the equilibrium attained from the two direction, then it is called as a true equilibrium. If the equilibrium attained from only one direction, that is called as the metastable equilibrium. Now we'll see about the Gibbs phase rule equation. So already we had studied about the phase rule equation, which was stated that the sum of the number of degrees of freedom, number of phases exceeds the number of components by 2, right? Remember the equation, that is F is equal to the phase rule equation, F plus P is equal to C plus 2, right? C plus 2. F plus P is equal to C plus 2. This equation is what's called as the phase rule equation. Now, here Gibbs have done some alteration, like he have arranged the same equation through which we can determine the degrees of freedom, that is F is equal to C minus P plus 2, right? So now based on this equation, he have given the statement that, or you can say it defined as, if the equilibrium in a heterogeneous system is not influenced by electrical, magnetic, or gravitational forces, the number of degrees of freedom of the system, the number of components, and the number of phases of the system are related by the equation there, that is F is equal to C minus P plus 2. The same phase rule equation was put forward, that is based on the phase rule equation only, right? He have just rearranged the equation by moving this p value toward this side. You got a minus p, right? C minus p plus 2. So this phase rule equation is called as the Gibbs phase rule equation, right? So now already we have completed with the phase rule. Now we have completed with the Gibbs phase rule. Now easily we can derive, like we'll see the derivation to derive this Gibbs phase rule equation. So here we'll start with the derivation, that is a derivation of a phase rule. So to start with this equation, right? So already we know the phase rule equation, that is F is equal to C minus P plus 2. So this equation we need to derive. So first what we need to do, we need to let us consider for each component the concentration variable is equal to P. And for the C component, let's take the number of concentration variable is equal to C is to P. P is nothing but the concentration variable, and for C component we are finding. So just you need to multiply C is to P. Now already we know the for two external variables, that is for pressure and temperature, the number will be is equal to plus 2. So here therefore the total number of variable will be is equal to Cp plus 2. Cp is for the number of concentration variable, and here 2 represents for the external variables. So hence we got the total number of variables is equal to Cp plus 2. Now when you consider the equation for P phases, right, the number of phase rule equation will be is equal to, let us take as P. In the same way, let us consider 2p phases gives you the number of chemical potential equation as equal to 1. And for 3 phases, the number of chemical potential equation will be equal to 2. In the same way, in general, when you consider for p phases, the number of chemical potential equation will be equal to p minus 1. Right? Whatever the number of phases you got, the chemical potential will be is equal to minus 1. 2p is there, therefore you got the value as 1. If 3p is there, therefore you got the value as 2. So in general, you can say that for p phases, the chemical potential equation will be is equal to p minus 1. Whatever the p value is there, from that you need to subtract minus 1. Therefore, you will get the number of chemical potential. Now, this same number of chemical potential, when you consider for the C component, as we have considered in the phases, in the same way when you consider for the C component, therefore the value will be equal to C is to P minus 1. C is for the C component, and for P phases, the chemical potential equation is P minus 1. Right? Therefore, the total number of equation will be is equal to whatever the p value you got from that value you need to add up with the number of component, or you can say the number of chemical potential with that of the number of phases. So therefore, the total number of equations will be is equal to p plus c is to p minus 1. Just we have added both the equations. This value will give you the total number of equation. So here we have calculated the total number of variable, and here we got the total number of equation. So now easily you can determine the degrees of freedom whose formula is equal to total number of variable minus total number of equation. So here the total number of total number of variables which you got here is Cp plus 2. So just you need to substitute this value as Cp plus 2. Next minus is there, therefore put the sign as minus. Next here, total number of equation, how much you got? That is P plus C is to P minus 1. That the same value you need to substitute over here. That is P plus C is to P minus 1. Right? So just we have substituted both the equations in degrees of freedom. Now, as this one is carrying a negative sign, so first you need to simplify it. So already we know minus into plus becomes minus, right? So here the same value you will get, that is Cp plus 2 minus P, right? Minus into plus becomes minus, therefore you will get the value as minus P minus, again minus into plus becomes minus Cp plus minus into minus becomes plus. Therefore we are putting a sign as plus. C ones are C. Now, when you observe this equation clearly, like here you are having a plus Cp value, here you are having a minus Cp value. So therefore both get cancelled. Now what is left? That is plus 2 minus P plus C, right? That these terms are left over. So now already we know like whatever the plus value is there, that you need to write first. And here if you are adding having alphabets with that of the number, means you need to write the alphabets first, then followed with the number. Therefore on rearrangement, you will get the equation as degrees of freedom F is equal to C minus P plus 2, which is called as the Gibbs phase rule equation. Right? So like this we have derived the phase rule equation by considering the number of number of variables and with that of the number of equation. I hope it's clear like how we have defined the Gibbs phase rule equation and how we had derived the phase rule equation. So if it is clear, then please like my videos and subscribe to my channel. Thank you.